All right, class, here we go. This is going to be our next lesson. This one goes over section 5.6, which is on simplifying radical expressions. This will be your homework assignment or your book assignment that you guys will turn into me. In conjunction with this book assignment, you guys will also have an activity that we will do in class to practice the concepts that we are covering in this lesson. I'm going to ask you guys to do this warm-up assignment, these 4 problems, please. Excuse me. Please complete these 4 problems, and you guys will turn these in for a grade at the start of our next class. All right. We're not going to go through every single page in this particular packet because I want to make sure that this is something approachable and it's really, really easy for us to drag out simplifying radical expressions. So here's what I want to concentrate on. We're going to concentrate on 2 properties. As you guys remember from the last video, radicals are really just fractional exponents. So anything you can do with an exponent, you can also do with a radical. There are 2 in particular that we need to talk about. The first one is called the product property. Product property says that if we have a radical, in this case we're going to use a square root, if we have a radical of a product of 2 things being multiplied together, this is the same thing as the product of the individual square roots. So if I have the square root of 8, the square root of 8 is really the same thing as the square root of 4 times 2. Let's try that again. The square root of 4 times 2. So I can break this into radical 4 and radical 2. So that's the product property for radicals. The next one is called the quotient property. This one says that if we have a fraction, a radical, a square root, we'll just say square root in general. If we have a root of a fraction, a divided by b, we can write that as the fraction of 2 radicals. So the square root or whatever of a over b would be the same thing as the square root of a over the square root of b, giving us this form here. For example, the cube root of 27 over 8 is equal to the cube root of 27 over the cube root of 8. Cube root of 27, if you guys want to remember that from last time for simplifying radicals, cube root of 27 is 3, and the cube root of 8 is 2. All right, there we go. Let's go to the next page now. Okay, so simplifying the radicals that aren't perfect. So if you remember from our last time when we were simplifying radicals, everything that we had kind of worked out to nice clean numbers, or if we had variables, everything kind of factored out and the radical sign went away. That isn't always the case. Now, the way I'm going to show you guys how to do this is we're going to still stick with prime factorization, so sometimes we're going to have terms that are left over. So like for this one here, we'll do the square root of 40, and then I'm going to have you try these 4 on your own. Ask me about these during class. If you guys get stuck on any of these, I will ask for questions at the beginning of class, and we'll see how you guys do with these. So the square root of 40, if I take 40 and I do the prime factorization of it, that's 2 and 20. That'll break into 2 and 10, which will break into 2 and 5. So the square root of 40 is really the same thing as 2 times 2 times 2 times 5. There's really an imaginary 2 up here for our index, so I can pull out groups of 2. So here's a pair of 2. I'm going to bring that to the outside. That's the only pair I've got. 2 and 5 are not the same thing, so I can't bring those out. So this leaves me with 2 times radical 2 times 5. I don't gain anything by breaking it up using the product rule because I can't take the square root of 2 and I can't take the square root of 5. So I'm just going to multiply these back together. 2 times 5 is 10, so that gives me 2 times the square root of 10 for a final answer. Go ahead and try that on these next 4. Pause the video, and after you guys have tried those, come back and we'll move forward to the next section. All right. Okay. Moving on. So we have another example here. This time we have variables though. Okay. Here's what I'm going to suggest you do. Use the product rule. We kind of did this the last time. We did it a little bit early last time, but it's the same idea. We're going to use the product rule. We're going to break this into the square root of 25 times the square root of p to the 8th times the square root of q to the 7th. Now there's lots of ways that we can do this. We can use the index rule, we can factor everything out, and we can simplify it that way, which is what I would suggest you do when you have constants. We can use our fractional exponent rule though and do something kind of cool though with these ones here. If you guys remember doing remainders when we were doing division of polynomials. Square root of 25 is perfect. So that's going to come out as 5. Let's talk about, well, let me see here if because we do actually do this in this section. Oh, we don't do it in this one. No, I'll go and show it to you now. Let's rewrite this radical as a fractional exponent. Okay, here's the rule that we're going to do. So we're going to have p to the 8th, okay, and the radical is 1/2. So we've got p to the 8th raised to the 1/2 power. That's what this is saying. We have p to the 8th, and we take the square root of it. Same thing over here. So we've got q to the 7th raised to the 1/2 power. Okay, we can use our product rule from exponents to combine some of this together. So we'll have 5, the coefficient. 8 times 1/2, I multiply these together. 8 times 1/2 is the same thing as multiplying by 1/2. So this will be the same thing as p to the 4th. Okay, this one here is 7 times 1/2. The problem with 7 times 1/2, though, is that 2 doesn't go perfectly into 7. We have a remainder left over. So 2 goes into 7 how many times? It goes into 7 3 times with a remainder of 1. Okay, if you guys don't remember that, think about how we did this with long division and stuff. So that means we're going to be able to take out we'll be able to take out 3 pairs of q's from 7. So if I write this out here, so I have q, 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 and 2 more, q and q. Here's a pair, here's a pair, here's a pair. So I can bring out 3 q's. When I multiply those 3 individual q's together, I will get q to the 3rd. But I have 1 left over q. Okay, that's still under the radical. So I'm still going to have a radical q at the end of my answer. So this is going to be the final answer for this problem. I'm able to take the square root of 25. P to the 8th, I can simplify it using our product rule for exponents. 1/2 goes into, 8 times 1/2 works out to a perfect number. 7 times 1/2 does not work out perfect, so it has a remainder, and that remainder is what's going to still be under the radical at the end. Okay? I'd like you guys to try these next 3 problems. All right, and when you're done with that, come back to the video. Okay. All right. I need to see if you guys are actually watching the video or not. So we're going to add something here. I know that I asked you guys to do these. Where is it? I asked you guys to do the warm up at the very beginning, and you were going to turn this in. In addition to this warm up, I'm going to be looking for 2 other things. The other thing I'm going to be looking for is I want to see number 1 from these 3 problems we just did. I want you to add number 1 to that warm up. So that's going to be these first 4 problems plus this number 1. So that's 5 problems so far. You will need to turn those in order to get full credit on this turn assignment. There's one more piece, and we're going to wait till the end of the video, and you will add that piece into it. All right. So we've simplified these out. Let's go to the next page. All right, like radical expressions, this is the apple and oranges argument that I give you guys in class. So if I have 3 root 5 plus 6 root 5 plus root 5, these are all root 5s. They're all the same radical. So I can just add them together. This is 3 of those, this is 6 of those, and this is 1 of those. So 3 plus 6 plus 1 is 10. Okay. As a counter to that, let's say I've got 3 root 2 plus 4 root 3. These cannot be added together because root 2 and root 3 are not the same thing. So this is the simplest form that this particular expression can be written as. Okay? You have to have the same radicals in order to combine stuff together by addition. All right. You guys can do these practice problems. I'll let you guys do that part on your own. All right, multiplying radicals. We have, all multiplying radicals is just the product rule in reverse. So the product rule says that if we have 2 things multiplied together and we take the radical, or we take the root of it, it's equal to the product of the roots. Okay. All multiplying radicals is doing is just starting here. We're starting here and we're going backwards. So here's the important part for this one. The indexes must be the same. Indexes... it's actually indices, I'm sorry. Indices must be the same. Must be the same. So the indices must be the same. Okay. Here, the indices are the same. We have an imaginary 2 here and an imaginary 2 here, so everything's good. So this will be the same thing as 3 times 3. 3 times 3 is 9. Another way to think of this is we have a pair here, so I can bring it out to the outside. So this will just be 3 when we're done. Okay. This one here, the indices are the same. Okay, we have a root 3, root 3, root 3, so we can multiply all of these together. 2 times 4, so we're going to do kind of an intermediate step here. We're going to ignore this part for a second. 2 times 4 is 8. 8 does have a cube. Okay, so the cube root of 8 is 2. If you guys don't know that, think about it for a minute. Work it out, do the prime factorization. So we have the cube root of 8 times the cube root of 27. The cube root of 8 is 2, and the cube root of 27 is 3. So this is really 2 times 3, which is equal to 6. Okay. This one here, again, we have the same values. 3 times 4 is going to be equal to 12. And then root x times root x. Root x times root x is just root x squared. So if you guys remember from our previous video, square roots and squares undo each other. Okay, that's the whole idea, is you're trying to find the value. So when you're doing a square root, you're looking for the value squared, or the value raised to the index that gives you x. There's really an imaginary 2 here, so this is asking for what value squared is equal to x. Okay, if you take that value and you square it, you just get x back. So this is just going to be equal to 12x in the end. Okay, let's see here. Simplify, then multiply, then simplify again, and there's actually no example here. That's unfortunate. Okay, we'll do some more of these in class. I'm not too worried about there being a missing example there. Okay, turn the page. Simplify these to the simplest form. So you're going to have to reduce these. I'm going to do the first one for you, and then I want you to try the rest of them on your own. And then we're going to talk about conjugates. How do I want to do conjugates with you guys? Go ahead and just FOIL these out, and we will talk about conjugates in class. All right, we'll talk about conjugates in class. So let's take a look at this one here. So root 5, I can't do anything with that. But the square root of 20 is the same thing as 4 times 5. So this is really the same thing as square root of 5 plus the square root of 4 times the square root of 5 by the product rule. Square root of 4 is 2. Okay, so this is the same thing as the square root of 5 plus 2 square root of 5. I have 1 root 5 here, and I have 2 of them here, giving me a total of 3 root 5s at the end. Okay, I would like you guys to try the same thing with the remainder problems here. If you guys have questions, ask me in class. All right, which brings us back to our warm-up really quick here. So our warm-up, I added a problem in the middle. You guys will need to go back and watch the video if you did not watch that to catch that. The very last thing I would like you guys to do is I would like you guys to write the word smile in the top left-hand corner, of your warm-up when you turn it in. So it gives you a bunch of things you have to do in order to get full credit on the warm-up. All right, so you will write smile in the top left-hand corner. Okay, that brings us to the last part of this lesson, and that is how to rationalize the denominator. The general rule for this is that there are no radicals allowed in the denominator. So if you have something like, let's do it here. I'm going to do this on a separate sheet of paper. So if I have something like 1 over the square root of x, you can't, here, let me kill that. I'm getting a lot of glare. Sorry. There we go. Okay, so 1 over root x. We're not allowed to have a radical in the denominator. This is a no-no. Okay, we have another convention, and that is that we're not supposed to have negative exponents in the denominator, which is something that you guys were working on when we were doing our exponent properties. Okay, so we have to get rid of this radical in the denominator. The general way that we do that is you need to remember this property, that the square root of something squared, the square root and the square cancel each other out to give us whatever the radicand was. In order to do this, we need to multiply, by whatever the denominator is. So we need to multiply by root x in the denominator. Whatever we do to the denominator, we have to do to the numerator. So if we multiply the bottom by root x, we need to multiply the top by root x, which will give us root x divided by root x times root x is root x squared, which by this is just equal to x. So this then becomes root x over x, and this will be our final rationalized form. You will need to be able to do that with problems here. Okay, so let's talk about how we do that. Let's look at an actual example here. This is going to take some practice, and I will come up with some of these. When we do our Jeopardy game in class, you guys will see an entire column that deals with rationalization of denominators. I'm going to save these two here, so I'm going to make up one that I'm going to put down here at the bottom, and we will do a rationalization problem together. So let's just do a square root. Let's do the square root of let's do the square root of 7 over. I'm just going to make something up here. Let's just do like b cubed. Okay. By the quotient rule, if I have the root of a fraction, I can take the fraction of the roots. So this will then become the square root of 7 over the square root of b cubed. Okay? We're not allowed. Square root of 7 is just some number. Just leave it as the square root of 7. If you guys, when we were simplifying radicals in the last session, you should remember this. Whenever you have like a radical of a prime number, it's going to be a really nasty decimal. Just leave it as square root of that number. So if it doesn't work out pretty, just leave it as the square root of whatever. Don't give me the crazy decimal. I don't want to see the crazy decimal. Okay. All right. So we want to get rid of the radical in the denominator. The index is 2. So in order to get rid of that 2, we need to figure out how to square this thing. So in order to square it, we just multiply it again. You will see rationalization problems where it is not a square. That'll be in the next section, I believe. And those problems get a little bit more difficult. So we're going to multiply by the denominator. So b cubed all over root b cubed. Okay. Multiply this out. This is really root b cubed squared. So the square and the square root b cubed squared. So the square root and the square are going to cancel out and we'll just be left with b cubed. So we get a b cubed in the denominator, and in the top we have 7 times b cubed. The b cubed does simplify. Let's take a look at that really quick. So b cubed, this simplifies. This is the same thing as root b times b times b. I can pull out a pair, which will leave me with b root b in the end. Okay, so that's really what this b cubed is. So this is really the same thing as root 7 times b root b. Okay, product rule. So multiplication is commutative, so it doesn't matter what order I do stuff in. So I'm going to put the b out front. Root 7 times root b is root 7b. So we're going to have b times root 7b, all divided by b cubed. And our last piece of simplification here, we have a b and a b cubed in the bottom. We can reduce that out using the quotient rule for exponents, and we get root 7b over b squared. All right, and that is our final answer for that one. Okay, a lot going on there. It was much prettier here, but we always try to simplify it out. Typically, as a convention, we don't like having fractions under the radical. We like to simplify it out into this form. Okay, you're going to do the same thing with these other problems. This one here, number 3, they say use the conjugate. So let's talk about what that means. It means you're going to multiply like we did in this problem back here. A conjugate is when you have a binomial. So an a plus b is a binomial. Okay. What we're going to do is the conjugate is a minus b. So multiplying by that does this. It gives us something called a perfect square. So a plus b, a minus b. If you FOIL this out, okay, if you FOIL this out, oh, where's my paper? There we go. So if you FOIL this thing out, you will end up with a squared minus b squared. Okay, that's how it FOILs out. If you don't believe me, actually try it. Actually try FOILing it out. So what we're going to do here is we have this radical 3. I need to be able to square this. If I just multiply by radical 3, when you try that, you'll actually just end up moving the radical 3 around. You don't get rid of it. We want to get rid of it. In order to get rid of it, we have to square just this part of the denominator. In order to do that, we have to multiply by the conjugate. So you're going to multiply top and bottom by 2 minus root 3. And then, which means you have to multiply the top by 2 minus root 3. FOIL that out and see what you guys get for that answer. All right. You're going to have questions. Mark them. Bring them to me tomorrow. We're going to do a Jeopardy activity in class, followed by, hopefully, we'll see how we do with the Jeopardy assignment and how we are doing with questions and answers. If we have time, we will do a Plickers activity at the very end of class. All right. Warm-up is due at the beginning of class. If you guys have questions, just bring them to me at the beginning. All right. I'll see you tomorrow.